Okay, so we are going to take a look at this half reaction. I'm pretty sure you have seen this video, assigned video already, so I don't have to really say too much about it, but let me just go over quickly about this half reaction stuff. So this is the equation that I'm actually interested. Right here, it says that Al solid, which is a zero charge, right? And then the nickel 2 plus charge is reacting with it, and then that Al becoming 3 plus, and then nickel become neutral, right? So this one right here is actually electron transfer reaction, and also that is really the oxidation reduction reaction, which is the redox reaction, right? Now, there is something funny about these equations right here. You may notice that before the reaction, the net charge right here is positive 2 on this side, right? Zero charge, positive 2. So 2 positive charge, and then that after the reaction, it becomes 3 positive charge and 0 charge, so the total charge is going to be 3 positive, right? That doesn't happen. So obviously there is a mistake in here, but I'm going to keep it as is, and then we're going to fix this one later. So in this class, everything is going to be conserved. If you recall what I said at the beginning of the semester, the only stuff that we do as a chemist is to change the location of atoms, right? So it won't change the total charge of the whole system. So the total charge has to be conserved, but for this reaction right here, it's not conserving. So we're gonna need to fix this one. So how do we actually fix this one? So let's just think about the half reaction. The half reaction is written here, but you get one of these reactions from the table as shown in here. So aluminum, I don't know if I can actually see the aluminum, it's right here, right? Aluminum, the sideway point arrow is pointing right here. And then the nickel, which is this one, right? So you have two separate reactions, the aluminum becoming aluminum 3 plus, and then nickel becoming nickel 2 plus, right? You have two reactions like this, and then somehow you're going to combine these two to create the reaction looks like this. Okay? So aluminum, the solid, is on the left hand side. So you don't really have to do anything for the aluminum, but nickel solid is on the right hand side, and the nickel 2 plus is in the reactant, the left hand side, right? So you're going to have to swap these things, right? The reactant and the product. Remember that the nickel solid becoming nickel 2 plus, right? So I just swap the reactant and product. Now, there is something else I have to do. The stuff that I need to do is, as it pointed out right here, where did it go? The total charge is not conserved, right? So the way to actually make everything conserved is to cancel out the number of electrons. So if you go to the aluminum half reaction, you have 3 electrons here. For the nickel reaction, you have 2 electrons here. So how do I actually cancel this one? I'm pretty sure you probably have heard of this least common multiplier. Is that least common multiplier? Yeah, probably. I'm not really good with that naming stuff, but what I'm trying to say is that for 2 and 3, what's the number that's divisible by 3 and divisible by 2 at the same time, and it's probably the smallest one. The smallest one, it doesn't have to be smallest, but it makes your life so much easier. So for this least common multiplier case, it's 6, right? 6 can be divided by 3, 6 can be divided by 2, right? So what I have to do is to actually multiply the entire equation of this aluminum half reaction by a factor of 2, and then multiply the half reaction of nickel by 3. If I do that, what's going to happen is that I have 6 electrons for aluminum half reactions, and then 6 electrons for nickel reaction, and that 6 electrons can be cancelled, right? Let me just give it a little bit prettier slideshow. Is that you have 6 electrons on the right hand side, 6 electrons on the left hand side. So if you cancel it, then it becomes exactly what we need. So that right there is a redox reaction in a complete form right here, which means that everything is conserved. So 2 aluminum, 3 plus, 3 nickel, 2 plus becomes 3 nickel, right? And then the number of species are conserved, right? Number of atoms, right? 2 aluminum atom, 2 aluminum atom, 3 nickel atom, 3 nickel atom. The charges, the total charge on the left hand side is 6 plus, right? 2 plus, you have 3 of those, right? So 6 plus. 3 plus, you have 2 of those on the product side, which is 6. So 6 positive charge on the left, 6 positive charge on the right. So everything is conserved. This is exactly what we need. So you're going to have to do this redox reaction using the half reaction to create the complete reaction. So let's go to the I think that's pretty much what I needed to do. Just read through the rest of the stuff here, and then those are assigned as a reading assignment, right? And then we are going to now try to solve the question number 3 and on the handout.